Welcome to the pre-prep session where we are looking at the geography optional individual test evaluation and re-evaluation, that is a mentorship program. So the first doubt question which we have here, that is the concept of plate tectonics has been derived from the isostasy and continental drift theory. Okay, so this is the main question. Now, in the next part, elaborate in suitable examples. So this is the question which have been asked by one of my students. So the concept of the plate tectonic, how it can be linked with the concept of isostasy and continental drift theory. We need to look at this particular aspect here. Okay. So what we will see here that first we need to have a quick background. So under this background, what we'll be understanding that it was the continental drift theory which was given by Alfred Wegener, who has proposed that the continents and oceans are not stationary. Okay, they are not stationary and they have been moving and drifting since ages. So in this part, what he has explained that he has given the part of the hypothesis with respect to the formation of Pangea during the Carboniferous period, which is almost around 250 million years ago. Then there was the breakup of the Pangea, resulting into the formation of Angara land and Gondwana land. Okay, but he has also given certain aspects here with respect to the formation of mountains, formation of islands. Okay, but what we will see here that the major postulate which was used for the development of the plate tectonics was the continents are not static. But he was not able to provide the forces behind the formation of the or the movement of continents and oceans here. So this is the first aspect. Now, second aspect, if we talk about the theory of isostasy. So under the isostasy, we have Airy and Pratt. So Airy has provided about the uniform density with varying depth. While Pratt has propounded that there is uniform depth with varying density. Okay, so this was based on law of flotation, and Pratt's idea was based on law of compensation. Okay, so these two ideas were provided here. But both of these ideas, it was made better by use of the plate tectonics theory, which basically had the idea of crustal bending. Okay, where we had a crust. If it is provided by a load, so there will be bending of the crust will occur here. So this was the major idea which was provided by plate tectonic theory. Here we'll be seeing that there was a component of varying depth with varying density, which was also provided by Bovey. Now, if we come back to the question, the concept of plate tectonics has been derived from the isostasy and continental drift theory. Elaborate with suitable examples. So here we have a background of the continental drift theory also, and we have a background of isostasy also. Now, in the introduction part, we can provide the basis of the continental drift theory, which was provided by Alfred Wegener, and the isostasy theory, which was provided by Airy and Pratt. So this basically formed the foundation in terms of the movement of continents and the formation of Earth's crust dynamism with respect to the vertical motion. And here we see that the movement of the continent, it is majorly with respect to the horizontal motion. Okay, so these two aspects is seen here, which is later resulted in development of plate tectonic theory during quantitative revolution and positivist approach. That is based on data and statistics. So this becomes one of the theoretical part for us to explain the background here, that how the continental drift theory and isostasy has resulted into the development and formation of the, we can say here, the plate tectonic theory. Now, in the second aspect, we need to interlink the question part, that the deriving of plate tectonics by isostasy and continental drift theory. Now, under this part, what we'll be seeing that, number one, we'll be talking about the continental drift theory. So it provided for the, basically, the drifting of continents. At various geological scale. Okay, though the forces were not explained correctly. Okay, where for the forces part, it was the plate tectonic theory, which have provided the forces, for example, the slab pull mechanism. Then we have uh, the ridge push mechanism. Then we have convection currents. Okay, so there are certain forces which have been provided by the plate tectonics part here. Second thing we'll be seeing here, the evidences which were provided, they were quite good. For example, the jigsaw fit. Okay, for example, Africa and South America. So this is the jigsaw fit which was provided here. Number two, minerals which were present in the form of Ghana coast. Okay, then if we look at the mountains, then here we have Appalachians. And here we can say the Scottish Highland. So these two mountains were continuous. Now, when we look at the other aspect, for example, the paleoclimatic evidences. So here we have the presence of glacial remnant over rocks or over lands. Here if we see that this is Earth. So this is Pangaea. This is equator. So the region which was present to the south of 60-degree latitude, it was having the presence of glaciers. So these glaciers are present in South India, southern part of Africa, southern part of South America, also certain parts of Australia. Okay, so these were seen here with respect to the glacial presence. Then the rock types. They were also quite similar in nature. For example, we have basalt, we have presence of marbles, schist, granite in the various regions of South America, Africa, and India. Okay. Apart from this, if we'll move ahead, we will also see that there is presence of fossils. Fossils of Glossopteros, then Mesosaurus, Listosaurus, etc. Okay, so these were certain evidences which were provided by the continental drift theory, which exactly said that initially there was a supercontinent which was Pangaea and a superocean which was Panthalassa. Okay, then there was formation of Angara land and Gondwana land. Okay, and there was presence of formation of Tethys Sea. Then there was the breaking up of the Pangaea, Gondwana land, okay, and resulting into the formation of various continents here, and along with their drifting. For example, Africa drifted northward, India drifted northward, while South America drifted westward, and North America drifted westward. So these were certain points which were provided under continental drift theory, which were basically used as the supporting evidences for the development of plate tectonics theory. So here we can say this aspect here. The drifting of continents then fossil remains, then mountains, etc., formed the basis of plate tectonics. Okay. Now, After this, we'll be looking at isostasy. Now, under isostasy, what it was seen that Airy has said that there are different crusts and different rocks which are having same density, but their thickness varied or their depth varied. So this was one of the concepts which was provided here. Now here he has given one concept of root formation. And here he has taken an example of, Mount Everest. So here we'll be seeing that as per the theory of Airy, the root formation, this was almost around 1 times. So this root formation, it will take almost around 10 times or 10x. Okay. So this was one of the concepts. Now, root formation is available for most of the continents or crust. But here we'll be seeing that as it was provided by Airy that it is ranging up to 10 times. This was not true here. Now, in the second part, when we look at Pratt, he has provided here that there is density of the crust. It is changing with respect to the changes in materials. For example, iron, magnesium, cobalt, copper, gold, etc. It can be anything. But all these crust or all these materials, they are following the line of compensation. And he rejected this law of flotation. The law of flotation as provided by Airy here. Okay. Instead, he used the concept of law of flotation, the line of compensation, where all the crusts, they are having a similar depth. Okay. Thus, he provided here the varying depth with, it is varying density with uniform depth. Now, they have provided certain evidences with respect to the process of sedimentation, then mountain building, then formation and melting of glaciers. So under the process of sedimentation, what is happening? For example, if a mountain is being built here, okay, mountain is formed. So along with the mountain, here we can see there is also formation of certain roots. Okay, there is formation of certain roots here. Now, after a certain period of time, when the denudation will start, it will result into the erosion of the mountains, and the same mountainous regions, it will be having certain part of sediments deposited along its edges. So because of this condition, what we'll be seeing that the isostasy will also change here according to the conditions of the deposition of sediments and the erosion of mountains. Similarly, if we'll look at this part for the glaciers and deglaciation, if this is the land, just take 2D part. So this is land, and here we see that during the periglacial age, there is development of ice. Okay, so because of the heavy load, what we will see here that this region, it will be having a root formation, and there will be certain amount of crustal bending will occur with respect to the plate. Okay, so this was the initial part, and this is the second part. Okay, where the crustal bending is taking place. And this will be vice versa when the glaciers will melt completely. The glaciers will melt completely. So there will be a rebound of plate will take place. So thus this concept was also taken under the plate tectonic theory, that it is not the crustal part which is bending, but the whole plate is bending or rising with loading and unloading process. So what it was explained here, how it was explained here. For example, in this particular region, there is formation of mountain has taken place. So because of the formation of mountain, there will be certain isostatic adjustment will take place here. So with this particular event, there will be the complete plate which will undergo the crustal bending with respect to the formation of the mountain here. So this was the process which was explained by the plate tectonic theory. Okay, this is the process which is explained by the plate tectonic theory, which is basically looking at the principle of elastic rebound. Okay, elastic rebound, the capacity of plate, and it has also said that the plates, they are quite flexible. The plates are flexible, therefore they are resulting into the crustal bending phenomenon. So we are able to interlink all these two processes. If we look example, so example is like the formation of Himalayas. Then there is also the mid-oceanic ridges. Then the coastal areas. Okay, which undergoes the subsidence process and also the rising process. Then we also have Hudson Bay region, where the glacial melting and formation and melting. This has resulted into the isostatic rebalance or adjustment here. Thus, looking at the conclusion, the continental drift theory and the isostasy concepts have been developed in the modern period and are part of non-catastrophic school. And this paved the way for the development of concept of plate tectonics theory during the postmodern phase under quantitative revolution, which is now the most accepted model for the continents and oceans formation in geography. Okay, so by this part, we can end our answer here. Okay, so we are able to interlink the background part. Okay, background part we don't need to explain, but yes, we need to have certain points here, which is needed us to explain the continental drift part. Okay, then isostasy part. Then here we can see the intro part, which is consisting of both the concept of continental drift theory and isostasy and interlinked with the plate tectonic theory. Then which part of the continental drift theory have been taken here? For example, the movement of continents, then the various evidences. Okay, here also we have taken the evidences here. Then from the isostasy, what were the concepts and how the concepts were developed. And these concepts were later modified by the plate tectonic theory. This is also explained here with respect to the elastic rebound theory or concept here. Okay, then we are concluding this answer here. Okay, so is this question okay? Do you have any doubt?
No doubt, sir, no doubt. I just uh, wanted to tell you that how I will structure my answer,
Okay,
and please tell me if this kind of structure is right or wrong. So
okay,
I'll first start with the introduction as you told, and here I'll just talk about some basic concepts that the isostasy and the continental drift theory talked about, and then the plate tectonics has improved over it. And in the body, I'll first start with isostasy, as the questions talks about isostasy first. Then the heading will be like derivation of plate tectonics theory from the isostasy. Then I'll talk about one concept of isostasy and then how it was improved by the plate tectonics theory. Similarly, I will give 2 to 3 or 4 points maximum about the isostasy. Then my second heading will be about the derivation of plate tectonics theory from the continental drift theory. Here also I'll talk about one concept of continental drift theory and its limitation and how it got improved by the plate tectonics theory. Similarly, I'll give uh, 3 to 4 points around it and then I'll conclude my answer.
yeah,
Is
it is
this a
also.
right approach?
Yeah, this is also good. See, approach can
Okay,
be
sir.
different. Your approach and my approach, it will be unique because we have different perspective and different thought process, and which is good. Okay, which is good. But what we need to see here that are we able to include everything here? For example, in the introduction or this part, I have just missed one important aspect, that is the development of this theory, the plate tectonic theory by Morgan, Mackenzie, who were other theorists here? Tuzo Wilson,
Yes, sir, it
along
was Wilson.
Parker. So these were certain theorists whose name has also to be mentioned here with respect to this part. See, what is important in this complete process that we need to specify that continental drift theory and the isostasy, it was formed during the modern phase. Okay. Then what we will see here that there was development of positivism, the scientificism inclusion in the geography. So therefore, the development of plate tectonic theory, it happened during the quantitative revolution, which was a part of the positivist approach. So this is also needed to be specified because we are developing a perception also along with the models which are present in the geographical aspect. Okay.
Okay.
Okay. So this is the first question.